Welcome to lecture 11. This is the continuation of remote sensing for natural hazard studies course. So, we have started discussing about the GIS in lecture 10. Now, we will continue that one. So, before I proceed, I just wanted to give you a brief introduction about the GIS. So, here you can see the GIS is a system designed to capture, store or manipulate, analyze or manage the data sets, right. Here there are few important terms. First one is capture, then store, then manipulate, analyze, manage and present, right. So, when we talk about any data set, considering you have collected a few data points in the field, which is basically the groundwater table, right. So, this is let us say groundwater table. You also have the information about the air quality. You also have the information about the precipitation. You also have the information about the surface water availability. So, all these information will be stored against this particular point, right. So, how system will remember or how you will remember that these parameters are stored for location X, right. So, that is why whenever we talk about the GIS, it has to be spatial or geographic data set. That means the latitude, longitude information, that means the location information, right, should be stored along with your parameter. Now, here we have generated the data set. Now, we will store it in the database. Then we will go for the analyzing, managing, that means you can also update the database. And then subsequently you will be generating a map which will display your information that you have collected. So, at a time you can generate one parameter information in terms of map, right. So, those will be called thematic map. That means this particular map has a theme. It can be rainfall. So, we will call it rainfall map. If it is air quality, then we will call it air quality map. If it is surface water availability, we will call it surface water availability map, right. So, like this we continue with this geographic information system. So, here the GIS allows you to integrate many data sets together. So, today I will be showing you one example where you will easily understand how we are integrating all the information collected by 2 or 3 people or maybe several groups across the globe, right. So, those things will be discussed today. Now, using this overlaying the information on top of another, that will enable you to visualize question, that means you will able to put the query, analyze the data set and interpret the data, and that will help you to understand relationship, pattern and trends, and this will be very easy once you have built the database in GIS environment, right. So, GIS is a organized collection of computer hardware, software, geographic data and a group of people who are involved in capturing the data, storing it and then updating the database, then analyzing and displaying the information, right. So, we will continue this with data versus information because we need to understand geographic information system. So, let us go step by step. So, we will start with the data that has been collected using remote sensing or maybe the conventional method, or maybe you have visited the field, you have collected some information, right. So, whether that data is information or both are different, right. So, they are significantly different. data is of little use unless it is transformed into information. Information is an answer to a query based on the raw data. So, I have one example that will help you to understand how the data is transformed into information. We transform data into information through the use of an information system. Now, you have a database, so we will call it information system. You put the query and then you will get the answer, right. So, here simplest example will be this values, right. So, here it will be difficult to analyze what it means, right, but once you provide this into the system, it will give you the letters, right. So, together they make the remote sensing, but it will be very difficult for us to remember these values, but our system understand only the numbers, right. So, this is data and this is information. Now, once we have the information, right, so we store it in the database, and then if we have any query, that will be put towards this information system, and then subsequently an answer will be generated. So, this is called information system, right. Now, here these are the examples of information system. So, we all have visited the library and we never go rack by rack to search a book, right. What we do? We refer to the catalog, and those catalogs will help you to find which book is where, right, and then you can directly visit that particular section and the rack, and then you will take out the book, right. Similarly, the phone book. So, the phone book it is very easy with the alphabet, it has been arranged. So, if you want to identify or you want to know the phone number of XYZ people, you refer those with those first letter of their name. Then nowadays there are different catalogs which are available. So, those will be used here, right. When we talk about digital information system, so digital information system basically it is the data in the digital form. So, all the systems are connected through each other through the internet, right, and together they are helping to get an answer that anybody put a query, right. So, here you can get the answer whenever you have a query. So, this is how we all are connected. So, we all are having smartphones, and every time GPS is on and the data sharing policies are nowadays very different. So, knowingly or unknowingly we are sharing our information, and that is helping others to get the information about a particular problem. So, if you want to reach A to B, right, and since you have shared your information that you took 10 minutes to reach this A to B, right. So, the next person when he or she search, that answer will be displayed that you will take 10 minutes to reach A to B, right, with certain traffic and the road condition and the weather condition. So, I hope this information system and digital information system both are understood. Now, when we talk about geographic information system, so here basically the spatial or geographic data is involved. So, here you have major section which is called data acquisition, then you have database management, and then you have qualitative and quantitative analysis. So, here this analysis, sky is the limit, any AI, ML, machine learning, any algorithm can be used or under the umbrella of GIS domain, right. When we talk about a particular problem, let us talk about a particular hazard. Let us say we wanted to generate a landslide susceptibility map. How we will perceive this problem and how we will start working with GIS, right. So, using remote sensing, GIS data and the field data and the conventional information or the historical data. So, how you will be able to use them together. So, the first step to see this particular problem is to define your problem. So, here we have defined that we wanted to have the landslide susceptibility map. Then define the GIS criteria, right, and then build or import the database. Then GIS analysis, here analysis can be anything, AI, ML or machine learning or the simple regression analysis, that is also possible. Then you are going with the output, and once the output is generated, then this will provide you the option of decision. So, here decision support system, whether this result is good, whether it is helping you or not. If not, then you need to modify your problem or you have to modify your GIS criteria, right. So, once you go through this entire channel, this is called typical structure of GIS, right. So, this is what I was talking about, the integration of the digital information. Now, let us say first group, the group 1, they have generated the capital information for a particular country. All these capital, the center of the capital that has been generated. So, they have generated the point map for capitals, right. Now, the next group, the group 2, they have generated the state boundary, right. So, this is polygon for state boundary. Now, the third group, they have generated the lake information which are present in a particular country, right. Now, the group 4, they have generated the road map, right, and then group 5, they have generated the information about rivers. Now, individually if you see, then you will be able to tell how many capitals are there for a specific country. Here you can say that this is the boundary of a particular state. Here you can say that these are the lakes present in this particular country. Here you can say this is the road network for a particular country. Here this is the river system or fluvial system of a particular country, right. But all of them are individually analyzed, but this GIS gives you the option to integrate all the data set together, right, and then this map will be something like this. Here you can see that one particular state, let us consider this is one state. So, within this, whether a river is present or not, whether capital is located at the center or at the corner of this state, and then whether it is connected or well connected with the road network or not. So, those information can be easily understood if you have digital data and in the GIS environment. So, GIS environment gives you more flexibility to analyze your data, to extract the information which were not possible to analyze when you had them in separate maps, right. So, here you are putting everything together in one place and then you are extracting the information, right. One very important output of GIS environment is the map, right. That map can be generated where you have north, south, the direction information, where you have the scale that will help you to know how far these 2 points on this particular map. Then this legend that will help you to gain the information about the different color or symbol used here, right. So, this map is very important because many times we need a map representation for our analysis, and that is possible with GIS. So, it is a informative 2D representation of 3D space. Basically, we are trying to convert this 3D information of our natural surface on 2D, right. So, this is map. It can be a hard copy representation on a sheet or a digital representation on a screen. Basic map characteristic tells the user where the object is and what is the object, right. So, here the location is very important, and the second thing is the attribute. Maps are equipped with scale, legend, and are defined onto a projection that helps in visualizing the curved surface of earth on the flat surface of paper or screen. So, here we will see one by one all these elements or the characteristics of map, or when you will be generating a map after your analysis, that will help you to convey the information in true sense, right. So, here this is the example of analog map where it is sketched and all these are approximate, right. So, this is not on the scale. Is it clear? But when we talk about the digital data, digital map, here the area, direction, everything will be proper, and because we are using a reference system to identify the position of the object, right. So, map in a GIS environment are used for input data. So, it can be digitized or it can be scanned, right. Querying map to put a query whether A is near to B, whether A is far from B, what are the locations which are 10 kilometer in the radius of this particular point. So, those things can be done. Display the result of remote sensing and GIS operation once you have derived the result or you have generated a landslide susceptibility, right. So, you want to represent the information. So, you need to provide or you need to generate a image, right. Execute and support visual analysis, and remember, maps are not only the final products. These are helping you to represent the information, but these are not the final products. This can be an input to your decision support system, right. So, map provide answers to questions related to the basic components of geographic data. So, the first one is geographic location, then you have thematic attribute, and the third one is the time. So, these characteristic of the map is very important because the location is very important, and without attribute your maps will be meaningless, nobody will be able to understand. And the time is important, whether this particular data has been generated in 2025 or it was in 1980, right. So, without this time your information cannot be understood. So, when we talk about the geographic location, here you see the location of this particular playa, or this is, you can consider this is a lake, right. So, this particular lake, what is the position, how it has been like generated. So, it refers, so the geographic location refers to the location of the place onto the earth defined by latitude, longitude. Longitude denotes the east-west position of the geographic location, runs north and south between two poles. Prime Greenwich meridian is assigned 0 line for longitude. Latitude denotes this north-south position of a geographic location, also called parallels, and runs perpendicular to longitude. So, this is latitude. Equator is assigned a 0 line for latitude. All latitudes are parallel to each other. So, now based on this latitude longitude, we are able to identify a particular position or particular target in the field as well as on the map. Then comes the thematic attribute. So, thematic attribute is like you are generating a map using a theme, right. So, it can be a rainfall, it can be a temperature or a human characteristics like population, health, etc. can be used to generate the map. So, these are the examples of thematic attributes. So, here it is annual mean temperature map of India, annual mean rainfall map of India, here it is elevation zone of India. So, here we are only talking about the attribute, but just remember the previous slide and refer to the time. If time is not mentioned here, annual mean temperature, that is not constant, right. So, without time this map is again meaningless. So, without time this map is meaningless. Now, the same thing happens with the annual mean rainfall map, but elevation zone that does not change very frequently. So, here though time is not very important here, but time is required because the topography is also changing with time, right. This is another example where you can see a particular river with reference to 1988, how it has migrated from this yellow line to this orange, right. So, how it is changing its position. Now, in 2002 with respect to 1988, how this has changed, right, and 1988 to 2014 how it is shifting, right. So, the whole river has been shifted. So, this is one very good example that how thematic attributes work and what information you can display using the thematic information. This is another example where this time is referred. So, January, February, March, April, May, June. So, in all these you see the change in the color, and as we have learned that red color, if this is false color composite, red color is basically representing the presence of vegetation. So, how it is changing? So, this is the seasonal change and here you can see the annual change, how a forest is growing, right. So, this is very important to use, or these characteristics of map are very essential whenever you are generating a map. So, maps offer abstract representation of reality that are simplified, classified and symbolized. This is how you are going to generate your image, whether it will be simplified, whether it will be classified, whether it will be symbolized. You will be able to understand in next few slides. So, maps are representation at scale, and scale is basically ratio between the distance on the map and corresponding distance on the ground, right. So, here 1 centimeter on the map is representing 50 meter on the ground, and in another one 1 centimeter on map represents 1 kilometer on the ground. So, in both the cases you see scale is 1:5000, 1:1 lakh, right. So, here this is very important whenever you are generating the maps. Now, these are the processes or these are the characteristics how you are going to represent your information. So, to represent the values you can use shape, you can use size. So, these shapes can tell that this is the x parameter, this is y parameter, this is z parameter, this is A. So, wherever you have this circle, you will say x is present, y is present with this triangle. So, similarly these lines can also tell you the strength of the values, right. So, this is thicker, this is thinner, right. So, similarly color hue, that can be also used, and here the color value, that can also be used, right. So, different color or hue, that will be used to represent the values. Then color intensity, that will help you to represent the value strength. So, if the value is very less, it may be light, if it is dark, that means value is high. Or different texture for different parameter or different object or target can also be used. Here this is a concise table which says if you have shape, you can use the qualitative differences. If you have size, you can go for the quantitative differences. Color hue, qualitative. Color value, quantitative. Color intensity, qualitative. Texture is qualitative and quantitative. So, if you have less population, a small one. If you have high population area, maybe the big circle, or different color with different values can also be used, right. So, those are the examples how you will be generating the map and how you will be representing your values in different symbols, color, texture or color hue, right. Now, as we talked about the simplified and classified map. So, whether my map will be simplified or classified, that has to be understood. So, here this is one example. This is the example of simplified map. Here everything is simple, all these boundaries are visible, right. So, this is very simple to understand, there is not much parameter here, but when you are trying to generate this symbolized and classified map. So, remember we had the classification, after classification we are generating the classified maps, and all the classified maps have different color or texture that will be representing different class or category, right. So, here this is yellow color, red color, green color, blue color, cyan color, they are representing different parameter, right. With this I will end this lecture, and the part 2 of lecture 11 will be continued. Thank you.